Theory of evolution. Proposed by Charles Darwin, the theory of evolution suggests that species change over time through a process called natural selection. Essentially, organisms with traits that are advantageous for survival and reproduction are more likely to pass those traits on to the next generation. Over many generations, this leads to the gradual accumulation of adaptations and the emergence of new species. The theory of relativity is like understanding that how you see things can change depending on how fast you're going and how strong gravity is. Special relativity says that when you're moving very fast, time can seem to slow down for you compared to someone who's not moving as fast. General relativity is about how gravity works. It says that heavy objects, like planets, can bend or warp the space around them. Quantum mechanics is the branch of physics that describes the behavior of particles at the smallest scales, such as atoms and subatomic particles. Unlike classical physics, which is predictable like gravity, quantum mechanics introduces probabilistic behavior and uncertainty. Key principles of quantum mechanics include wave-particle duality, where particles exhibit both wave-like and particle-like behavior, and the uncertainty principle, which states that certain pairs of properties, such as position and momentum, cannot be precisely measured simultaneously. Warning: quantum mechanics is notoriously difficult to comprehend because it challenges our intuitive understanding of the world at a fundamental level. Even when one grasps the basic principles, further exploration reveals a maze of baffling phenomena and mathematical frameworks that often defy conventional logic. Explaining its intricacies merely scratches the surface of the profound mysteries that lie within this fascinating field of physics. The Big Bang Theory proposes that the universe began as a hot, dense state approximately 13.8 billion years ago and has been expanding ever since. This theory is supported by evidence such as the cosmic microwave background radiation, the observed redshift of distant galaxies, and the abundance of light elements in the universe. According to the Big Bang model, the universe started as a singularity, a point of infinite density and temperature, and has been evolving and cooling over billions of years, leading to the formation of galaxies, stars, planets, and ultimately, life as we know it. Plate tectonics theory explains the movement of Earth's lithosphere, which is divided into large, rigid plates that float on the semi-fluid asthenosphere beneath them. These plates move due to the heat-driven convection currents in the Earth's mantle, causing phenomena such as earthquakes, volcanic eruptions, and the formation of mountains and ocean basins. The theory of plate tectonics provides a framework for understanding the geological processes that shape the Earth's surface and the distribution of continents and oceans. Cell theory is a fundamental concept in biology that states that all living organisms are composed of cells, and that cells are the basic units of life. The theory originated in the 19th century with the work of scientists such as Matthias Schleiden, Theodor Schwann, and Rudolf Virchow. According to cell theory, cells can arise only from pre-existing cells through cell division, and they contain hereditary information passed from parent cells to daughter cells. This theory revolutionized our understanding of life and laid the groundwork for modern biology. Germ theory of disease proposes that many diseases are caused by microorganisms, such as bacteria, viruses, fungi, and parasites. This theory was developed in the 19th century by scientists such as Louis Pasteur, Robert Koch, and Joseph Lister, who demonstrated that specific microorganisms were responsible for infectious diseases. Germ theory transformed medical practice by emphasizing the importance of sanitation, hygiene, and the development of vaccines and antibiotics to prevent and treat infectious diseases. Theory of gravity. Gravity is the force of attraction that exists between all objects with mass. According to the theory of gravity, formulated by Sir Isaac Newton in the 17th century and later refined by Albert Einstein's general theory of relativity, gravity is the result of the curvature of space-time caused by mass and energy. Gravity governs the motion of celestial bodies, such as planets, stars, and galaxies, and it plays a crucial role in the formation and evolution of the universe. Atomic theory is a scientific theory that describes the nature of matter in terms of atoms, which are the building blocks of all chemical elements. The modern atomic theory originated in the early 19th century with the work of scientists such as John Dalton and Dmitry Mendeleev. According to atomic theory, atoms are composed of a nucleus containing protons and neutrons, surrounded by electrons and orbitals. Theory of electromagnetism. Electromagnetism is a branch of physics that describes the interaction between electrically charged particles and magnetic fields. The theory of electromagnetism, formulated in the 19th century by James Clerk Maxwell, unifies electricity and magnetism into a single theory, known as Maxwell's equations. According to this theory, electric charges produce electric fields, while moving charges, or currents, produce magnetic fields. Electromagnetism plays a fundamental role in many phenomena, including the behavior of light, the operation of electric motors and generators, and the transmission of electromagnetic waves, such as radio waves, microwaves, and light. Theory of natural selection. The theory of natural selection explains how species evolve over time through the process of adaptation and survival. Organisms with traits that are better suited to their environment are more likely to survive and reproduce, passing on their advantageous traits to their offspring. Over generations, this leads to the gradual evolution of species, as individuals with beneficial traits become more prevalent in the population. However, it's important to clarify that while natural selection is a fundamental mechanism driving evolution, they are not the same. Natural selection plays a key role within the broader concept of evolution. Chaos theory. Chaos theory studies complex systems and how they behave unpredictably, even though they follow deterministic laws. It explores phenomena such as the butterfly effect, where small changes in initial conditions can lead to vastly different outcomes. Chaos theory has applications in various fields, including meteorology, economics, and biology, helping us understand the intricate dynamics of nonlinear systems. Game theory. Game theory is a mathematical framework for analyzing strategic interactions between rational decision makers. It explores how individuals or organizations make choices to maximize their outcomes while considering the decisions of others. Game theory has applications in economics, politics, biology, and other fields, providing insights into competitive behavior, cooperation, and negotiation strategies. String theory. String theory is a theoretical framework in physics that attempts to unify the fundamental forces of nature, gravity, electromagnetism, weak nuclear force, and strong nuclear force, by describing elementary particles as one-dimensional strings rather than point-like particles. String theory proposes that these strings vibrate at different frequencies, giving rise to various particles and forces observed in the universe. Although still a subject of active research, string theory offers a promising approach to understanding the fundamental nature of the universe. Doppler effect. The Doppler effect describes the change in frequency or wavelength of a wave, such as sound or light, when the source of the wave and the observer are in relative motion. For example, when a car with a siren approaches you, the sound waves are compressed, resulting in a higher frequency and a higher pitch. As the car moves away, the sound waves are stretched, causing a lower frequency and a lower pitch. The Doppler effect has applications in various fields, including astronomy, meteorology, and medical imaging.